the textbook talks about high probability set and compare this set with the typical set. Basically, the idea is very simple. So typical set is the small set that accounts for the most of the probability, and the high probability set is also a set which accounts for the most of the probability, but it aims to minimize the size of the set, and then it doesn't have to be have to have the typical property. So this one is very easy to see with my example number 5 given right here. As you can see, the typical sequence pivots around 2 ones. So by controlling the epsilon, you can include this set and also this set. So these 3 sequence sets can be made to belong in the typical set by controlling epsilon. So you may not include this most probable sequence in such epsilon. But if you consider the high probability set, then you must include this one, because this one is the smallest single sequence that has largest probability. So you have to have this one first, and the next one, which is this one, which only have 100 sequences, and that account for probability of 0.27. So a high probability set must have this one next, and this one next, and this one next. So the order is different. The high probability set expand this way as you increase delta, but the typical set start from here and then you expand out, right, this way as you increase epsilon. So those are the 2 sets, how they are different. But if we account for the most of the probability, then these 2 sets must similar to each other, and in terms of the order of exponent, it is the same. That's what basically this theorem says. So basically, in terms of exponent, these 2 are almost the same. Just it differs only by this much. Okay, and when this difference, when we take a look at with this definition, it is only epsilon. Okay. So that's high probability set versus typical set.